Why is xargs necessary? Suppose I want to remove all files in a directory except for one named notes.txt. I would do this with the pipeline ls grep notes.txt xargs rm. Why do I need xargs as the output of the second pipe is the input that rm should use? For the sake of comparison, the pipeline echo #include an lt knowledge.hmgt cat_gt foo.c inserts the echoed text into the file without the use of xargs. What is the difference between these two pipelines?
You are confusing two very different kinds of input, stin and arguments. Arguments are a list of strings provided to the command as it starts, usually by specifying them after the command name, for example, echo these are some arguments, or rm file1 file2. Stin, on the other hand, is a stream of bytes, sometimes text, sometimes not, that the command can, optionally, read after it starts. Here are some examples. Note that cat can take either arguments or stin, but it does different things with them. Xargs can be thought of as converting stin-style input to arguments. Echo actually does more or less the opposite. It converts its arguments to stout, which can be piped to some other command's stin.
Cat takes input from stin and rm does not. For such commands you need xargs to iterate through stin line by line and execute the commands with command line parameters.
Understand xargs with a minimal example. Before looking into why xargs is useful, let's first make sure that we understand what xargs does with some minimal examples. When you do either of xargs parses the input string coming from stin, and separates arguments by whitespace, somewhat like bash, though the details are a bit different. In particular, spaces and new lines are treated differently if you use xargs L instead of N, this URL. Because we are not using L however, both of the above calls are equivalent, and xargs would parse out 4 arguments, 1, 2, 3 and 4. Then, xargs takes the arguments it parsed out, and feeds them to the program we are calling with. In our case, it is the executable /user/bin/rm. By default, xargs does not specify how many arguments it is going to pass at a time, and unless we pass some flags, and it could be more than one. So the above xargs calls could be equivalent to either or. And we generally don't know which one of the above happened because for rm, the end result would be the same. Files 1, 2, 3, and 4 would be removed, so we don't care much about which one xargs is doing anyways, so we just let it do its thing. It could make a difference for other programs, for example /user/bin/echo however, where a new line is added for every call. Control how many arguments are passed at a time. We can control how many arguments are passed at once to xargs with certain flags. The simplest one is n, which limits the maximum number of arguments to be passed at a time. Then, we can try to observe what is going on by using /user/bin/echo instead of /user/bin/rm, because echo, unlike rm, treats echo1-2 differently than echo1, echo2, as it adds a new line for each call. With this in mind, if we run, it supplies 2 arguments at a time to echo and is equivalent to which produces. And if we instead run, it supplies 1 argument at a time to echo and is equivalent to which produces. Another way is to use L instead of N. L is like N but only splits by new lines, not spaces, this URL. And another common way to control the number of arguments is I, which implies L1, for example, is equivalent to, and so produces. Alternative approaches and why xargs is superior. Now that we understand what xargs does, let's consider the alternatives and why xargs is better. Suppose we have a file, notes.txt. Instead of, we might want to use, which expands to. However, this is problematic because there is a maximum size for the command line arguments of a Linux program, so it could fail if there were too many arguments in notes.txt. Xargs knows about this, and automatically splits arguments intelligently to avoid having too many at a time. And there is no maximum size to streams like stin, so things can work to arbitrary sizes like this. The reason why it works is that streams can be read little by little with the read system call, while CLI arguments must be loaded all at once into virtual memory, so there is no need for a hard maximum on stream sizes. Another simple approach you could try would be from this URL, but this requires a lot of typing, and could be slower because it calls the /user/bin/rm executable once for every argument, rather than fewer times with a bunch of arguments. More time is spent on the bash while loop, as opposed to the C-coded xargs code. To make xargs even more interesting, the new version that a P option for parallel operation. Related, this URL.
If you want to support your channel, please consider subscribing.